We'll stretch, friends. We'll stretch. Some of you come from a class. So we'll stretch. Join us, Enzo. Join us. Phone away, kiddos. Phone away. Phone away. Thank you. Thank you. Ready. Let's inhale. Deep breath, hold. And birthday candle. Ready. Deep breath, inhale. Hold. And birthday candle. Those of you at home, unmute and join us for a word of prayer in class. All together, let's pray. Sovereign Lord, help me for your name's sake. Out of the goodness of your love, deliver me. Amen. Go ahead and have a seat, folks. You may briefly get out your cell phones if you legitimately use them for the calendar function or a planner of some sort. So if you actually use your calendar on your cell phone, get it out. So your homework tonight is your next preview video. It's shorter than last night. Last night was kind of introduction. Heads up, you have 2 assessments next week. An Alex quiz on day 1. You will be doing your Alex quiz take-home practice quiz partially in class on day 4, which for you guys is Thursday. And your written quiz day 2 next week. There will not be a practice for that. There'll be no homework next Monday night. What your homework will be to go over your lessons so that you get to review and use them on the written quiz. So it'll be up to you how you study for that. Highly, highly recommend that you have physical papers with your lessons, because it's a lot easier to shuffle through paper than it is through like 26 slides of class cake. Yes, ma'am.
Is the written quiz the written test, or is this test?
It's a 50-point quiz that will take the entire period. So if you want to call it a test, you might guess, but it's 50 points, and normally tests are 100. So it's a quiz. Yes, we are. 2,000 points. Yes. Okay. Got it. Okay. Go to the first page of today's lesson, friends. First page of today's lesson. Get your handouts on that. Get a calculator handy. You'll need it eventually. The 20th. Yes. Tuesday. B-Day. Yes. And we are right here, friends, right here. And take a look at my hover cam here, friends. Actually, let me introduce. So what I'm going to show you right now is this orange here you're about to see is represented in this circle. So there's going to be a wedge in the orange, and it's going to be a 60-degree. We're going to pretend it's a 60-degree wedge. So just go ahead and shade that right there. Shade it. Shade that right there. So that little wedge is represented now by this orange. So what I want you to see here, before we do anything else, everyone put 2 fingers up like this. 2 fingers, you guys at home, 2 fingers. Repeat, 2 fingers, 2 fingers. Say arc measure.
Arc measure.
Arc length.
Arc length.
Not the same.
Not the same.
Do it again, say arc measure.
Arc measure.
Arc length.
Arc length.
Not the same.
Not the same.
That's really important. In about 20 seconds, arc measure and arc length seem like it's interchangeable. We say, what's the measure of this room? What's the length of the room? It seems like it's interchangeable. It's not in geometry. Watch very closely. This orange slice right here is 60 degrees. That was the central angle. Therefore, this arc, degree measure, complete my sentence in class, measure of a central angle to its arc, the great. So the measure of that arc is going to be 60 degrees. Put this here. Be very careful with this word measure. We're on the left-hand side. You got it. Okay. So go ahead and sweep this and put it 60 degrees. Here's another way to say it. The curvature of the arc is 60 degrees. Measure curvature. That's what you're associating with. Arc length is something different. Go ahead, underline that word length. Taking a look here. Length would be as if I take this curved piece and I flatten it. And if I want the length of this, it is a fraction of the length around. Out loud, what do we call the length around a circle? Out loud? Okay, nice and loud. What do we call length around? Therefore, arc length is a fraction of circumference. You guys at home, unmute and say this with me. You guys in class, repeat after me. Say arc length is a fraction of circumference. So it's not a measure here. That's why you can flatten arc length. So here it is. This stuff's really easy once you get the hang of it. Just right up here, arc length, write fraction of, we're just going to use a C for circumference because I'm too lazy to spell it out. You're not on your calculators right now. Thank you. And the way we do that fraction is we do part over whole, which is the central angle theta over 360. That's part over whole. Of is multiplying C. That's Miss Way's attempted dancing. Yes, okay, you got that close. So theta over 360 times d pi. This, my friends, is the equation for arc length equals. See that equation? On your next page, you'll see this here. Wherever you see arc length, I want arc length equals, that's where that equation goes. Just the FYI. Let's do this one together. So our theta here is going to be 60 over 360. Please, I beg you, always physically trace straight across the diameter. Never use your eyeballs for that. Pi. Hands off the calculators, friends. The key to multiplying is not multiplying, it's factoring. The key to multiplying is not multiplying, it's factoring. The key to is not multiplying, but factoring. So I want you to challenge yourself, guys. Do not touch your calculator until you get the last result pi form. Then you may grab your calculator. Try to train yourself. I'll do this one with you. Watch carefully. Okay, step number 1, divide 0. That's easy. Step 2, there's like 3 ways to do this. I'm going to go 18 and 36. Jessica, in honor of your first day here, 18 and the 36. It's an even number. 2, yep. So that's a 1, that's a 2. Going this way, 2 into 6, Sid. 2 into 6, kiddo. 2 into. Yep, 3. Congratulations. Your answer here for arc length is 3 pi centimeters. Now, approximately. Now you grab your calculators, get the decimal form. Go. And I want both answers for every single problem, friends. Pi form and decimal form. Yes, sir. Yes, sir.
What if you like 6 divided by 60 divided by 36?
Sure, you could have done this, kiddo. If you saw it, you could have done 1/6 of 18 and got the same thing.
Yeah, but then 3 times 18.
The 6 is down below, kiddo.
Oh.
The 6 is down below. It's
Yeah, no,
1/6
sorry,
of.
sorry,
Yeah,
sorry,
yeah.
That makes more sense.
Okay, so get your decimal form. Now, sector area, this one down here, sector area is very, very similar. Except instead of fraction of circumference, looking at my orange, it would be the pope here. This is a fraction of the area. Sector, fraction of the area. Repeat after me, say sector. Fraction of area. Really simple here. So it's almost the same equation. Just right here, say fraction of area. So you start theta over 360, same thing. Of is multiplying. Apple. Okay. And so we have pi r squared. That's sector area, friends. This one, 160. 360. I might recommend that you do not multiply out that radius. Instead, just do your square, but leave both pieces. It's easier to factor if you pull it apart. And then just leave pi here as an afterthought. Hi there, Taylor, what's the first thing I can reduce, ma'am? There's more than one way to do this, so don't panic, it's okay. Hi, Taylor.
You could do 160 and 360.
That's right. So kill the zeros. That's one thing I can do. You guys at home, you're doing this with me. Armand, what can I reduce next, sir, now that I got rid of the zeros?
You can divide.
Which one by which one, sir?
You can divide the pi.
Don't touch the pi, sir. We're reducing numbers. You're looking at 16, 12, and 12, and 36.
You could divide 16 and 36 by 2.
Let's choose a larger number. What's the largest number that goes into both of them?
8. Wait, no.
Try again, between that. Not 2, not 8. What goes into both of them?
4.
Bingo. So we're going to take circle, circle, divide by 4, and divide by 4. That gets us a 9. And you just keep hacking it away. Kayla, tell us, what can we reduce now?
Wait, what was the question?
What can we reduce now, ma'am? I got 12 and 9.
well.
What can I do with that?
You can reduce them both by 3.
Okay, fabulous. That's a 4, and down here, that's a 3. All right, we're almost there, folks. Riley, what's the last thing we could do here? Hi, Riley, what's the last thing we can do here? We got a mic issue. Mic's not working. Okay, Keaton, what's the last thing we could do here?
I did it a bit differently and
That's
reduced a bit
perfectly
of
fine.
different numbers.
There is a faster way to do this. That's perfectly okay, but what's the only thing we can do left?
1 and 4, so then you get 4 pi.
Almost. So we go like that, and that's 4, right? So that you end up with 4 times 4 times 4 pi. Okay, which is 64 pi, check for units, inches squared. There's literally 4 or 5 ways to factor all of these, but I want to train yourself to factor before you try to use calculators. Only use a calculator to get to the decimal. Okay, turn the page. Let me show you what you're responsible for, folks. You are responsible, because I'm going to hack something. You're responsible for page 2. Oh, by the way, folks, when it says sector area, this is the equation you're using. Let me highlight it for you. That is sector area equation. And that is what's going like here and here. So page 2, page 3, on page 4, folks. Yes, you are doing the bottom problem. The top problem is going to become extra credit, because normally there's a physical model for that, and not everyone can get their hands on the physical model. So if you get that one correct, it's up to 3 points extra credit, but don't try it until you're done with everything else. Those of you in class, when you get to that problem, if you want to use a physical model, I can actually do the demo for you. Okay, students at home, if you are not ready to be left alone, send me a quick chat. I'll pull you into a breakout room. Who in class would like to do another problem with me? You're just not ready to be left alone. That's perfectly fine.
We actually figured out our dimensions for like 8.
Say that one more time.
We actually figured out our dimensions for like 8.
Oh, college, you willikers. Yes, fine. Okay.
You want to come over? Sure.
Okay, kiddos, you should be able to go like that without bumping into anybody. Ta-da! Little space, big space. You should be able to helicopter without smacking someone. Well, it's totally up to you. That's where you put the equation. Wow, okay, kiddos, everyone at home, so there's no confusion, of course, there's an equal sign for the equation because it's equal. So what goes here on the left
Oh, my bad.
is the word arc length.
Yeah, okay.
Yeah, equals theta over 360 times d pi. And this is sector, okay, ladies, we don't too close. You should be able to stick your arms out without smacking each other. So a little broader, Denise, Marika, a little broader. Okay, and this one is gonna be sector, and that's theta over 360 times pi r squared. Okay, so you can talk to each other. Okay, guys, I have it right here. I have it right up there, Marika. Can you see it? Is that too messy, my dear?
Wait, what is the second word say?
Okay, you guys at home, anyone want to do another problem with me? Carissa, Sophia, Riley, Nadia, Joshua, Rachel.
I'm good, thank you.
Okay, towards the end of class, if you want the demo for the extra credit problem, I will do a demo for that.
Did you get 3? Sophia, did you get 3 five? Yeah.
Okay, guys, ladies and gents, look up here. I have your 2 equations you need up there. Okay, gentlemen, you should be able to helicopter. I can't spread out more than you That way I can bring it up and you can look at it. That's why I like to be good. Great, it's just getting right across.
Okay, is that it? Or not?
Still, yeah. Because I have to look back and break up and then you what I'm doing.
Is everyone following? Are we leaving anyone behind?
No, it's okay. It's hard to communicate because it's kind of your immediate area. So I can actually. How you doing, man?
28, 27.
Don't forget units. Nice. Units, don't forget units. No, that's just.
I would do it.
Can I just see? Let me get a dry erase. That one over there.
Which one are you on? You get art length or
Are you on the left and right? Right. Okay, so
whoa, where are we?
over.
Yeah, and then you gotta do like, yeah.
Okay. Still 0. 9. Which is,
What question are we on right now? What is it? Yeah.
So maybe we use variable or
Oh, so we're using.
Oh, okay.
Yeah, we choose something. Oh, wow. Over 3. So then you have 1. Got it?
So now I have 9, and then let me put it over 36. You're done.
Oh, yeah.
I don't think
Okay, this way. Yeah, I'll be there in just a second.
7, right? Okay, now you're on. Hold on. You're 21. No. Oh, wow. And then for sector, sector area, and then it's 14. It's not really over the summer that
I got
so
49.
change my hours to be the hours topic, so I can do them over the summer.
Not, you see, we purchased the geometry prize. I don't think we're allowed to translate them, but send me an email and I will at least ask. I will at least ask. Yeah, get me the decimal version. Okay, I'll be right there. Carissa? Smart? Here you go. Smart, can you check in on Jessica Allen once in a while and that's like magic? Yeah.
Oh, and then you can cross it out and redo it. 27 over
Sweetheart, welcome to the most 2736.
7 times 7 is what? 49.
That works too.
I'm 3. Oh my God. Okay, thank you.
Okay.
Oh my God.
Declan, do not be so paranoid about how you do that.
I got
270 over 360.
I got 270 over
Are you on the 145?
I'm on the.
90? I'll be right there, man. So it's 90 over 360 times. Well, sorry, well,
No,
five.
I didn't, I think I'll get drilled.
I wish I could tap that, so I could go back.
No, you're not. No, that's what I got.
You're done.
Wait, can you go with me?
For what?
For the first one?
I got, if I did it times it by 5, I got, 3 pi.
Oh!
Yeah.
Thank
That's
you.
what I got. Yeah, I don't know why. I didn't.
All right. I'll be right there, Hermione. Give me a second. I need to see the weight of my attention's now here, so I gotta make sure I don't ignore my home kids. So, hey, friends in Zoom, questions? Let me check in with you real quick. By name, tell me what problem you're on and if you have questions, okay? Carissa and Kayla?
I actually finished early, so I'm done.
Did you take a shot at the extra credit? Would you like to see a physical demo of the extra credit?
Oh, sure.
Okay, so if you need to, you can leave. I'm gonna do a physical demo of the extra credit for everyone since you're a little ahead of the game in about 7 minutes, okay?
Okay.
Okay, Carissa, you doing okay? Oh, Jessica, just FYI, that candy's for everyone. You get 1 candy every time you're here.
I'm good.
Good. Miss Abby and Keaton? McKenna?
Very good, thank you.
Good. Stick. If you're pointing, stick, sweetheart. Nadia, Mira. Nadia, Mira. Rachel, you guys doing okay? Joshua?
I'm good, thank you.
Mira?
I'm
There,
I'm
ma'am?
good, thank you.
Okay.
I'm doing good too. Sorry, I couldn't.
You doing okay? Thank you, Nadia.
Divided by 5.
What the heck? Where did you calculate four? Oh, we usually go by I got 9/2 times 7 pi.
Okay, why don't you give me the original? The original is 145.
270
No, it's 270.
over 360 times 28 pi.
Okay, goodbye zeros. Now what?
We divided by zero.
Huh? Oh, huh?
Wait, how do you get 9 over divide by 3? That's 9. I divide by 9.
That's fine. 9, 12.
Yeah.
Now
I know we
keep going.
divided up 12 and then 9.
Yeah, so 3 and 4.
12, you get 3 and 4.
Oh, that's got 28.
Boom, boom. Right, 7.
And then that's 1. Wait.
You just have to keep track of what's left over.
You did,
So, guys, what I like to do is when I know it's my final answer, I like to box it or something like that. Did you see what I did there?
oh, okay.
Friends, this would be a lot easier. You always want to look for the biggest factor. Okay, just FYI, so you can see it. 27 and 36 have something in them.
Oh my gosh.
9. Biggest number possible. That's 3, that's 4, boom, boom, 7, 21. You always want to go for the largest factor possible. Okay, come over here. Let me pull it up and do a share, because you're not the only one, because it ends up in a fraction and it freaks people out. Okay. Brianna, you wanna join Jessica and I? Because we're doing a problem that ends up being a fraction, and for most people, that freaks them out. Yeah, let me double check. Okay, so Jessica, I'm on page 3. So arc length equals theta over 360 times d pi. You okay so far, ma'am? Okay. What's our theta? We're just gonna do it together. What's our theta here? So we're gonna go 145. This is beautiful. Over 360. And then Brianna, what's our diameter? 36. So right off the bat, we can't kill zeros because there's no zeros, right, Brianna? But what can I do? Which gets you what? 10. 10. Okay, so I go like this. That's 10. Are you good so far? Okay. And then you divide by 5. And that is 2, and that is, I think it's 29. No, 29. It is 29. It is 29? Yes, so your answer is 29 over 2 pi p. You're most likely, Jessica, bothered by the fact that it's a fraction and you think you're right. That's okay. I've been trying to get people over their fraction phobia all day.
13 minutes.
Does that make sense, kid? Okay. Yes, ma'am? Yeah, top? On the right? Okay, so we have 145 over 360, 18 times 18 times pi, right? What'd you start with? That's perfectly fine. So we got a 1 and a 20. Now what?
And then we did 125 over 20, so 29.
So that would be 5.
Yeah.
Okay, so that's going to be 29 over 5. No, 4. Take that back. 4. And?
And then we did 4 into 18, so 2 over.
Uh-huh.
And then we multiplied.
Yes, sweetheart.
Oh, that's right.
Oh, so we're having this conversation because it's over 2, right? Yes. Fractions are fine. In fact, fractions are preferable to decimals. Yeah, do take it into decimal form, because once in a while you'll have to do something else with it. Students, I will do the demo for the extra credit in about 5 minutes. Nico, ditto. Dick, follows fails. I'm sorry, I'm gonna get smaller sticks. So it's not that's what I tend to like talking about. Getting some practice and that's incorrect if it's not a practice. Are you on? No, child. Here, let me show you what that looks like. No, I do not like decimal fraction. Exact term is fraction. You need to go over your reversion to fraction.
Yeah, that's what I got.
Says exact high form.
For this question.
High form and decimal. When you use high form, it's the fraction. So for example, this one is 145 over 360 times, what's our diameter? Okay, so step number 1, that cancels that 10, right? Okay, 5 goes in here 29 times, 5 goes in here twice. The pi answer starts 29 to pi, whatever the units are squared. That's pi. The 145 and the 10 is divisible by 5.
Okay, so that'll be 239.
So, yeah, the 29 over 2 pi. And that's the form I want.
Oh, so you don't do anything else?
Well, then you take it to decimal.
The 14.5.
But when you do high form, you have no decimals, it's a fraction form. Makes sense?
Wait, so from this, how do you?
29 divided by 2 times by 5. If you can put up with my hand right now, I can do it. You guys doing okay? Yeah, it's a fraction, you know? Get over it, it's okay. It's fine. It's not a full fraction.
I got it. No, our entire.
9, 8, 12, 9, 8.
So there was an additional 9.
Students at home, I'm going to be doing a demo of the extra credit in approximately 2 minutes. Yes, it is 29 over 2. Okay. Ready? 145 over 360, 18. Start. What? Oh, you did this by 5? Okay, 29, 72. Stop it. What? That's fine, that's 1, that's 4. Stop it. That's what I did. 2, 9, so it's 29, that's 9. You have to forgot to multiply these.
Okay,
That's 1, 18, 26, so it is 261 over 2.
Oh, that's what I didn't want. I didn't want to slide.
Yes, ma'am. How is it? Okay, the sprinkler. So how much of the circle is it? It's a quarter. Yes. So that's your first order of business. Is your sprinkle area is basically 1/4, right, of a circle that has a radius of 12. So it's 12 squared times pi. You're gonna need, because I have to do something else with it, I have to get another decimal point. Does that help? Okay, and then whatever this is, you divide it by the area of the entire yard to get what is that sprinkler percent coverage. Because now you're a landscape and you're figuring out if I want 100% coverage, how many sprinklers do I need? Yeah, that's what you're doing. Does that make sense, Rana? Okay. Which is the quarter of a circle, right? Okay, so the second here, we clean them up. I have, you have to be very careful here. So I'll give you the scenario and then I'm gonna let you. The only thing different. Like a quarter of a circle. Finding the area, right? Dog leash. So dog is here. 482. Okay, so you can go there, go here, go here, go here. See, that's why you go around the corner. Yes, there is as far as you can. So your question is, what is this area that the dog can go? Realize that you can't go around this way. Let me figure out if it's wrong. All right, have fun. Students, I'm going to demo the extra credit here slightly. So I'm gonna get my demo.
I got 11%. That's wrong. So let's figure out what's right. Yeah. Oh, it is right. It's right. It's not drawn skill.
No, it is not drawn to scale.
So I just found, okay, they gave us the radius. So I just found the area of the circle divided by 4. This is the right angle of the circle right here. And then I found the area.
Okay, am I actually talking to anyone at home? Holler at me so I know who to address.
The area of this quarter circle by the area.
Anyone at home want to see the extra credit? Okay, anyone in class, guys? I'll demo the extra credit here.
Hold on, it depends on what time it is.
It's 3:25, 3:27.
Oh, okay, no, I gotta pack up. Yeah, I gotta go.
Oh, guys, it's so much fun. Anyone at home want to see this demo? If not, I won't waste my time.
I'll watch.
I can watch it.
Totally up to you. Okay.
I'm
let
not
me
gonna
just
be
give
able
you
to
a
do it, but I can
scenario.
watch it.
This is the dog planner. 3 feet. The only difference here, it goes out to 10 feet. Okay, so imagine this is 10. This is the dog leash. It's 8 feet. But you're asking yourself this, if the dog can roam this way, and the dog can get around the corner, what is the area that the dog can roam? That's your question. The dog can go this way, around this way, and can get around the corner, at least partially. So the question there is, what is the total area that the dog can roam?
We have to do that for credit.
No, you don't have to, dear. That's why it's called extra credit. Okay, it's the dog problem, the dog leash problem. Yes. So I'll leave that up to you guys to figure out. Hang on just a second. Kids in class, so remember, correct your work and then turn it in. The good news, Jessica, is, give me just a second. Huh?
Can I print that?
By all means, yes, sir. So the good news is, if you finish your class and you correct your class, turn in tray will be done. Oh, well, then it's my. Get track that out. Okay? If you have a different, that's okay. Take a minute. If you need to correct it on the loaded at the class, pick like usual, that's perfectly fine. Kids at home, last chance for a question.
Can I turn it at home?
Yes. of
Thank you.
course. All righty, guys, bye now.
Bye. Have a great day.
Shall do. Thank you, Rachel. Thank you, Miriam.